Welcome to this lecture. So, in the earlier lecture, I will talk about introduction to approximation methods which are used to solve the problems for the bound state. And now in this chapter, I will talk about one such approximation that we call as perturbation theory. So, the title of this lecture is Time Independent Perturbation Theory for non-degenerate state. Is the title of this lecture. Now, before discussing the perturbation theory, let me describe the meaning of the word perturb. So, the dictionary meaning of perturb is to disturb. And this disturbance should be very, very small in the context of our problem, that this disturbance should be very, very small. And so if I think in terms of our problems of physics, then this perturbation is caused by some external agency. Perturbation is caused by some external agency, and the reasons for this might be some electric field may cause this in general, magnetic field may cause it, some gravitational field may also cause it. But in quantum mechanics, we will not worry about in this context gravitational field. So we will talk in terms of electric field and the magnetic field. So when perturbation is caused by electric field, it leads to Stark effect, and when it is caused by the magnetic field, then it leads to Zeeman effect. So what will happen when these external agencies, means electric field or magnetic field, acts on the system? Then the total energy of the system will get changed. That means total energy gets changed. Or in other words, I can say that there is a slight change in the Hamiltonian of the system. So that means how Hamiltonian will change. So let us have a look at that. So let H naught is the Hamiltonian of the unperturbed system, and at this Hamiltonian will slightly changes. That means some additional term will be there, this HP, and our actual Hamiltonian will become H. So this is basically the Hamiltonian corresponding to perturbation. right? And this perturbed Hamiltonian should be very, very small. So if W is the interaction, W is the interaction term, causes system to be perturbed, right? Say if electric field is passed through or the magnetic field, then electric or the magnetic field, these are the interactions, because this electric field will interact with our system which is unperturbed. But this should be very, very small, so that means the additional factor lambda will also be multiplied by with it, and this lambda should be very much less than 1. And because of this, we can assure that this perturbation is very small, right? So this is a way that how we will start developing a theory for the perturbation theory. And this W may be because of the electric field or the magnetic field or anything else. It will represent the interaction because of these things. And another thing is that this lambda is dimensionless. I think no need to talk about it because sometimes this may affect the thing. So this lambda is a very small number, right? So I think this is more than enough. Now, to develop perturbation theory, okay. So to develop perturbation theory, let us recall time independent Schrodinger wave equation. That is H psi n is equal to E n psi n. Let me call it as equation number 1. Here H is equal to H naught plus HP, and this HP is nothing but lambda W. So therefore equation 1 will become that H naught plus lambda W psi n is equal to E n psi n. Call it as equation number 3. So this is Schrodinger wave equation for perturbed system. And let phi n be eigenstate of unperturbed Hamiltonian H naught be the eigenvalues En naught. So therefore, we can write down the Schrodinger wave equation for the unperturbed system as this H naught phi n must be equal to En naught phi n. So this is equation number 4, and let me call it as Schrodinger wave equation for unperturbed system. Right. And let us assume that perturbation causes very little change in the eigenvalue of the energy in comparison to unperturbed system. So that is, mathematically we can say that total energy of the total eigenvalue energy of the unperturbed system is equal to En naught plus lambda En1 plus lambda square En2 and so on. And here this is basically the eigenvalue energy corresponding to perturbed system, and this is basically the eigenvalue of energy, means this term eigenvalue of energy corresponding to unperturbed system. Unperturbed system, and these other terms are basically the correction terms introduced here, means there is a slight change in the energy, so these are corresponding to that. And similarly, I can write down the eigenfunction. Similarly, eigenfunction corresponding to perturbed system can be written as psi n is equal to phi n plus lambda psi n1 plus lambda square psi n2 and so on, and let me call this as equation number 6. Now when we use lambda is equal to 0, when we use lambda is equal to 0, then equation 5 and 6 becomes solution of unperturbed system. So that means perturbation is basically depending upon this. The extent of perturbation is depending upon this parameter lambda, right? So means this leads to that En is equal to En naught and psi n is equal to phi n, right? Now in perturbation theory, our objective is to determine En1, En2 and so on, psi n1, psi n2 and so on. Now let us use, so for this let us use equation 5 and equation 6 in equation 3. So if I do that, then how this equation can be written as, this is h naught lambda w, it is the value of this psi n, then the psi n is equal to phi n plus lambda psi n1 plus lambda square psi n2 and so on, is equal to En naught lambda En1 lambda square En2 and so on. It is phi n plus lambda psi n1 plus lambda square psi n2 and so on. Let me call this as equation number 7. Then let me try to simplify this equation, and this simplifies as follows. This is h naught plus lambda w, and this multiplied with this whole, this with this and this, so it is phi n plus h naught lambda w psi n1 plus h naught plus lambda w psi n2 and so on. Now this factor gets multiplied with all the terms, and then this with all and this with all, so it can be written as plus En0, sorry, not plus, what is equal to, yeah, so it is En0 phi n plus lambda En0 psi n1 plus lambda square En0 psi n2 and so on. Then this term gets multiplied with it, and then this will resolve. So it is lambda En1 phi n plus lambda square En1 psi n1 plus lambda cube En1 psi n2 and so on. Now then lambda square En2 phi n plus lambda cube En2 psi n1 plus lambda 4 En 2 psi n2 and so on. And let me simplify these terms. So here this term can be written as, this is h naught phi n plus lambda w phi n plus h naught lambda okay, lambda is also sitting here and lambda square is also sitting here. So here it is plus lambda h naught lambda h naught psi n1 plus lambda square w psi n1 plus lambda square h naught psi n2 plus lambda cube w psi n2, and this must be equal to, this is only one term, so en naught phi n, then lambda terms are there, so there is one lambda term, there is another lambda term, right? Only two lambda terms are there. That means I can write down these together, plus lambda en0 psi n1 plus en1 phi n plus lambda square terms are there. So this is one lambda square term. In this side there is another lambda square term and there is another lambda square term. So and so on. So I can write down this as like this, that en0 plus psi n2 plus en1 psi n1 plus en2 phi n, right? So these are the terms. So if I equate because these are two lambda terms and these are the lambda square terms, so let me recollect these again. So it means this equation will become h naught phi n plus lambda h naught psi n1 plus w phi n plus lambda square h naught psi n2 plus w psi n1, and this must be equal to E naught phi n plus lambda en naught psi n1 plus en1 phi n plus lambda square en naught psi n2 plus en1 psi n1 plus en2 phi n plus n, so on, plus n, so right. So let me call it as equation number 8. So now I will compare the coefficient. This is a constant term independent of lambda. This is a lambda term. This is another lambda term towards other side, and similarly these. So that means if I compare comparing corresponding coefficients of lambda on both sides, then for zero order in lambda, I can write down it as this h naught phi n must be equal to E n naught phi n. Let me call it as equation number 9. Now for the first term or the first order in lambda, and then second order in lambda, so how things can be written? For the first order, I can write down it as this h naught psi n1 plus w phi n must be equal to E n naught psi n1 E n1 phi n, and here it is h naught psi n2 plus w psi n2, sorry, not psi n2 but psi n1. It must be equal to E n naught psi n2 E n1 psi n1 plus E n2 phi n, and let me call this as equation number 10 and it as equation number 11. Now our purpose is to calculate En1 and En2. So since psi n is considered, let us use a trick that since psi n is considered not to be very different from phi n, that is phi n and psi n is nearly equal to 1, and using this, let us assume that keeping this in mind, let us assume that phi n and the psi n is equal to 1, and let me put their values here. This is the equation number 12. So if I put its value of psi n, then how things can be written? This is phi n, and here it is phi n plus lambda psi n1 plus lambda square psi n2, and so on. This is equal to 1, which implies phi n plus lambda phi n psi n1 plus lambda square phi n and psi n2 is equal to 1. But as we know from normalization condition that this is equal to always 1, right? So 1 plus some other thing is always equal to 1, and this is possible if and only if rest of the terms containing lambda will become 0, right? This is then and only then possible. So it means we can say that lambda phi n psi n1, because lambda can never be 0, they are non-zero numbers, so that means rest of the terms must be equal to 0 and so on, they are equal to 0. So if lambda is not equal to 0, that means this fact leads to the conclusion that this phi n psi n1 must be equal to phi n psi n2 equal to and so on, then all are individually equal to 0, and let me call it as equation number 15. Then to calculate en1 and psi n1, let us proceed as follows. So now consider equation 10. So let me write down the equation number 10. This is h naught psi n1 plus w phi n is equal to en0 psi n1 en1 and phi n, operating both sides with phi n. So if I operate with the phi n, then what will happen? Let us see. This phi n h psi n1 plus phi n w phi n, it must be equal to phi n e naught psi n1 plus phi n en1 and phi n, and since its eigenvalue is equal to when operated with phi n, then its value will be en0. So keeping this in mind, I can write down this as en0, it is phi n psi n1 plus phi n w phi n must be equal to en0. This is phi n psi n1 plus e1 phi n and phi n. As we know that this value will be 0, this value is also 0, and this value is 1. So that means I can simply write down it as that En1 is equal to phi n W phi n. Call it as equation number 16. Therefore, En is written as, if we use first order correction term, then En is equal to En0 plus En1 multiplied with lambda. So it is En0 plus phi n W phi n multiplied with lambda, and it is En0 plus lambda, sorry, not lambda but phi n, lambda W phi n, and this lambda W is nothing but it is HP. So it is En0 plus phi n HP phi n. So therefore I can sum up the result. This as En is equal to En0 plus phi n HP and phi n, right? So this is the eigenvalue of energy with first order correction term. Now the calculation of psi n1. So since phi n is form a set of complete and orthonormal bases, so therefore I can say that phi m and the phi n is equal to 1, and summation over m and phi n and phi m is delta mn or nm. And let us now consider psi n1 is equal to psi n1 and multiply with it 1, but 1 is nothing but is equal to this one. So if we put this value here, then I can say that it is equal to summation over m phi m phi n, sorry, it is m and psi n1, and let me rewrite this equation. So this can be rewritten as phi m psi n1 both put together, and it is a summation over m, but m is not equal to n. This is because of the fact that why it is not equal to m, because phi n and psi n1 is always equal to 0, as we did earlier. Let me call it as equation number 18. Now again consider equation 10. This h naught psi n1 w phi n, it must be equal to En0 psi n1 plus En1 phi n, multiplying both sides or operating both sides by phi m. So if I operate this with this, then it will become phi m h psi n1 plus phi m w phi n is equal to E and 0. This is phi m and psi n1 plus E n1 phi m and phi n, and corresponding to it, its eigenvalue is equal to em0 because I am operating with m. If it is here, it is n, then it should be n, but here it is m, that's why it is em0. So it means it is em0 phi m psi n1 is equal to phi m w phi n equal to, it is okay, and okay, it is n and m, okay, and yeah, n is not equal to m, and this makes it 0, and this is also 0. No, this is not 0. Yeah, so let me do one thing. Let me club all these terms. This is okay. Equal to E n 0 phi m psi n1 and this will become 0, and this makes it okay, E n and this towards that side. It means this phi m, not phi m, yeah, phi m w phi n is equal to E n0 minus E m0, because both are similar, so it can be taken outside. It is phi m and psi n1, and from here I can write down the value for this. So that means phi m psi n1, it comes out to be phi m w phi n divided by E n naught minus E m naught, and this is equation number 19. And using this value in equation number 18, and equation number 18 will become that this psi n1 is equal to summation m is not equal to n, it is phi m w phi n upon E n0 minus E m0 and phi m, and let me call it as equation number 20. Therefore psi n will become phi n plus lambda psi n1, it is equal to phi n plus lambda summation m is not equal to n, it is phi m w phi n over E n0 minus E m0, and it is phi m, and this lambda gets multiplied here and it will become hp. So therefore this psi n can be written as phi n plus summation m is not equal to n, it is phi m w, not w, but it will become hp, because when lambda gets because lambda w will hp, right? This when multiplied with it, so it is hp and phi n divided by en0 minus em0, and it is phi m, right? So that's what is the total wave function with the first order correction, and let me call it as equation number 21. Now next part is the calculation, is the last part of this. So now calculation of en2, it is the second order correction. Now for this, consider equation number 11, and equation number 11 is h psi n2 plus w psi n1 must be equal to en0 psi n2 plus en1 psi n1 plus en2, and it is phi n. Operating both sides with phi n, we have to operate with it. So if I operate with it, then it will become phi n h psi n2 plus phi n w psi n1 must be equal to phi n en0 psi n2 plus phi n en1 psi n1 plus phi n en2 phi n, right? That's what I did. Now simplify this equation, and here its eigenvalues will be equal to en0, so that means it can be written as, it is en0 phi n psi n2 plus phi n w psi n1, this is equal to en0 phi n psi n2 plus en1 phi n psi n1 plus en2 phi n, and the phi n, as its value will be equal to 1, its value will be equal to 0, its value is also equal to 0, and its value will also be equal to 0. So that means this leads to the fact that this en2 is equal to phi n w psi n1, right? Because this is 1, so that means this term is basically equal to this term, and this is equal to 1, right? So now if I put the value of this here, or I can say that if I recall the value of this psi n1, as I know that psi n1 is equal to summation m is not equal to n, it is phi m w and phi n, it is en0 minus em0, it is phi m. So if I put this value here in equation number 22, then En2 will become this En2 will become phi n w m is not equal to n, phi m w phi n divided by En0 em0, it is phi m. Now bringing this inside, if I bring it inside it, then how this equation can be written as this phi m w phi n over En0 minus em0, and here it is phi n w phi m, and summation m is not equal to m. If I put these two terms together, then it can be written as summation m is not equal to n, it is phi m w phi n, its mod square, and it is En0 minus em0. So basically this is the value for what we call En2. Let me call it as equation number 23. Therefore, this En can be written as En is equal to En0 plus lambda En1 plus lambda square En2. So it is equal to En0 plus lambda phi n w phi n plus lambda square summation m is not equal to n, phi m w phi n square En0 minus em0, and when lambda gets multiplied with it and it, so it will become lambda w whole square, so it will become hp. So that means this En is equal to En0 plus phi n hp phi n plus summation m is not equal to n, phi m hp and phi n its mod square whole divided by En0 minus em0 plus and so on, and say it is equation number 24. So hence we have calculated first order and second order correction terms, and total energy corresponding to these terms can be calculated for the perturbed system. So that's all for this lecture, and thanks for watching this lecture.